So guys, welcome to our channel once again. In today's video, we have here these 4 questions to answer on the topic electric field. So guys, this video will be about the Coulomb's law. So ensure to stay till the end of this video. Let's go ahead and start with the first question here. So it has a diagram here, and the question says, the diagram illustrates 2 charges, particles W and X. The charges on W and X are respectively A, negative, positive, B, negative, negative, C, positive, positive, D, positive, negative. So option B here is the correct answer to this question, guys. That's negative, negative. So let's also bear in mind that in the conventional flow of current flows from the positive to the negative terminal. So if you look at this diagram, you see the charges flowing to the center, all the arrows pointing towards the center, and that shows that the charges, the center of this is negative. So, and as well, you'll see that these 2 charges are like charges since they repel each other here. So that shows that the both of the charges are negative, negative. And that's it for this question. So let's go ahead and consider the next question, guys. That's question number 2 here. It says 2 identical charges situated 20 cm apart in vacuum repel each other with a force of 10 Newton. Calculate the value of each charges. So let's take 1/4 pi epsilon naught to be 9 times 10 to the power of 9. And then the options we have here, A is 2.1 microcoulomb, B is 3.6 microcoulomb, C is 4.4 microcoulomb, and D is 4.0 microcoulomb. So guys, let's go ahead and solve this out together. So here we have that F is equal to KQ1 Q2 over R squared. So with this, we can say FR squared is equal to KQ1 Q2. But then, since the charges are identical charges, it means that Q1 is equal to Q2. So we can actually rewrite this to be FR squared is equal to KQ squared. So at this point, to find Q squared will be FR squared over K. But let's recall that K is equal to 1/4 pi epsilon naught, and that has the value of 9 times 10 to the power of 9 Newton meter square per coulomb squared. So with this, we can actually substitute for this value and every other value here. So we have that R here is 20 cm, and 20 cm is 20 over 100, which is 0.2 meters. So our force already here is given to be 1 Newton. So we can go ahead and substitute all these values. So we'll have 1 Newton times 0.2 to the power of 2 over 9 times 10 to the power of 9. So that's it. Let's go ahead and calculate this and get down to the answer. So when you do this, you have 4.44 times 10 to the power of negative 12. So when you do this, Q alone is going to be the square root of this and that 2.1 times 10 to the power of negative 6 coulombs. And guys, this is 2.1 microcoulomb. And that's option A here. So that's it for this question. Let's go ahead and consider the next question, guys. That's question number 3 here. It says, two bodies each carrying a charge of 2.00 times 10 to the power of negative 10 coulombs are 5 cm apart. Calculate the magnitude of the force between the charges. So take 1/4 pi E naught to be, okay, there is a little error here. So let's just go ahead and solve this question together. So here we are still going to use the formula F is equal to KQ1 Q2 over, let's say, D squared. So now let's take note that Q1 and Q2 are also carrying the same charge here. So for this, F, remember we are trying to calculate the magnitude of the force. F is equal to K times Q1 Q2, that's 2.0 times 10 to the power of negative 10. Now this will be squared since it's Q1 Q2 and Q1 Q2 are the same, and that's it here. So we'll square this, and then this will be over 5 cm, and 5 cm is 0.05, which is squared here. So 0.05 squared will be here at the denominator. So we'll go ahead and resolve this as K times 4 times 10 to the power of negative 20 here. And this will be over, so 0.05 to the power of 2 will be 0.0025. So here F is going to be K times, okay, let's go ahead and do 4 times 10 to the power of negative 20 over 0.0025. That's 1.6 times 10 to the power of negative 17 here. So if we multiply K by this, K is 9 times 10 to the power of 9. So that will be 9 times 10 to the power of 9 times 1.6 times 10 to the power of negative 17. This will be 1.44 times 10 to the power of negative 7 Newton. So that's option D here, and that's it for this question. Let's go ahead and consider the next and last question, guys. So that's question number 4 here. It says, which of the following action would increase the electric force between two positively charged particles? We have A, decreases the mass of the particles. B, increasing the distance between the particles. C, increases the mass of the particle. D, decreases the distance between the particles. So guys, also take note again here that the relationship between the electric force and the distance between the particles will be F varies inversely as d squared. So if F varies inversely as d squared, it means that F is equal to k over d squared. So it means that when you increase d squared, you're reducing F, and then when you increase F, you're going to reduce d squared. So in order to actually increase the force between the two positively charged particles, you have to reduce the distance between them. And guys, that's option D here. Decreasing the distance between the particles will actually increase the force. So that's the answer to this question, and this is where we end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.